In this video we're going to take a look at gradients for National 5 applications. Now the good news is that gradient is given, the formula for gradient is given in the formula sheet for Nat 5 apps. And the gradient formula, we usually use the letter M really for gradient, is vertical distance, or vertical kind of height, over horizontal distance. And we usually use H for that, so it's V over H. And that's something we're probably all familiar with anyway, coming from first maybe to third year, that's been encountered before. A couple of things that we need to make sure we watch out for with gradient is that we are using matching units. So if I've got meters and centimeters, I'm going to want to get them to match and so on. Something else that we want to watch out for is that we're actually using the correct values. It needs to be vertical, which is perpendicular to the base of the shape, okay, and obviously horizontal. If not, we may occasionally encounter Pythagoras for these questions where we've got to work out what the missing value is. But those are really the two key things that we need to remember. As gradient is obviously kind of given as a fraction, we can compare gradients in one of two ways. We can keep them as fractions, but then we would have to get denominators being the same for us to easily make comparisons really. Or we can recognise that a fraction is actually just a division, and if we do that division and turn it into a decimal, we could also make comparisons. So those are some things that we want to watch out for gradient. So let's take a look at some of these past paper questions. So we've got this question here, we've got a ramp that to allow wheelchair access to a scale has the dimensions shown below. The maximum gradient for a ramp with this distance is 1 over 14. Does the gradient meet the regulations? Use working to justify your answer. So we've got a paper 1, so it's non-calculator. Gradient is vertical over horizontal. And we are told that vertical straight up at 90 degrees is 25 centimeters, and the horizontal distance is 4, so the units need to match for this. Obviously it doesn't matter which way you do it, I can convert either way. Let's convert 4 meters into centimeters by multiplying by 100 because there are 100 centimeters. These are key facts that must be remembered. So we've got 25 for vertical over 400, and because it's a fraction we want to make sure we're simplifying that as far as possible, and 25 divided by 400, we can divide it by 5, but believe it or not we can also actually divide it by 25, but you would get there eventually by breaking it down, and that simplifies to 1 over 16 by dividing through by 25. But like I say, we could divide by 5 and then actually divide by 5 again. So the gradient's 1 over 16. We've got a gradient of 1 over 14 that it is not allowed to be bigger than. And actually, although the denominators are not the same, hopefully we can recognise that 1/16 is less than 1/14. Okay, although the denominator is bigger on the bottom, it's 1/16, so it's been split into 16 parts. So we need to do nothing for this one, we don't need to convert to get matching denominators. So all we need to do is write down a wee statement saying yes, as 1 over 16 is less than, and we can use this wee symbol, 1 over 14, and that's us answered that first question there. Okay, so we need to make sure units matched up, but then we're given the formula. If it's a fraction and it's paper 1, simplify it as far as possible and then make that comparison. When you're making your statements, please ensure that you do actually make a comparison between the numbers. Don't just write yes or no. Make sure you justify it. Let's look at the next question. So we've got, the diagram shows a planned zip line for a park. it's recommended that the average gradient should be between 0.06 and 0.08 to be safe. Does it meet these recommendations? Okay, so something slightly different about this is that we can kind of see that, it doesn't take a right angle triangle shape for the gradient as such. So we need to be careful about the height that we are using for this. Now, if I just very carefully, obviously I can't do it particularly accurately, we've got to recognise that this is really the shape that we're working out the gradient for. So the height isn't 17, the height is actually 15 for the slope. The height of the actual slope is 15 metres, so that's something we've got to watch out for. Again, this is paper 1, so we're going to need to do this without a calculator. So gradient is vertical over horizontal. Vertical is 15 metres and the bottom is 200. That's also obviously in metres, so we don't need to do anything with that. If we simplify that down by dividing both by 5, we get 3 over 40. Now we're told that the gradient of the line should be between 0.06 and 0.08. We've got a fraction, we've got decimals, so we need to get them to be the same. So I need to actually do 3 divided by 40. And when I'm dividing by 40, that's the same as dividing by 4 and dividing by 10. But remember, you can do that in any order. So if we do 3 divided by 10, move the decimal point, that's 0.3. Divide 0.3 by 4. We get 0 4's fitting into 0, carry that on. We get 0 fitting into that. Add another 0 and carry that on. We can fit 7 4's into 30, that makes 28. So we've got 2 remaining and 5 fit into 20. So the answer to that is 0.075. So we've got 0.075, has to be between that and that. So we can write the statement again. Does it meet the safety recommendations? Yes, as 3 over 40, which was 0.075, is between 0.06 and 0.08. And that's all we need to do, just making sure that we, in our statement, we actually make comparisons between the numerical values. Okay, question number 4. When classifying mountain bike trails, the gradient of the steepest section is taken into account. We've got different colour grades depending on the max gradient for that. The new trail has been built and the steepest section of the new trail is shown. Can it be classed as a blue trail? Use working to justify your answer. So for a blue trail, it's this one up here. The max gradient is 3 over 20. So if our gradient is bigger than 3 over 20, it can't be used as a blue trail. We need to work that out. So the gradient is vertical over horizontal. Vertical would be 1.6 and horizontal would be 8. Okay, and we could technically simplify that down, but because we're then trying to compare that with 3 over 20, what I would always say to do really, especially if you maybe struggle with fractions more, is turn them into decimals just by doing division. So 1.6 divided by 8 is 0.2, and we're then comparing that with 3 over 20. So 3 over 20 just means 3 divided by 20, and that means 3 divided by 10 and then divided by 2. So 3 divided by 20 divided by 10, 0.3, divide that by 2 is 0.15. So that's what the maximum gradient is for a blue trail. So my answer is no, as the gradient, we could say 1.6 over 8, which was actually 0.2, is bigger than 0.15 for the blue trail. So it can't be classified as that. Okay, let's look at the last question in this video. We've got the diagram below shows a staircase Mark intends to install in his home. The dimensions of the riser and the tread are each shown below. So tread is basically the width of the stairs and the riser is the height of each step. It says, for safety reasons, these rules must be applied. Twice the riser height plus the tread depth should be 625 millimeters plus or minus 15. So that's actually tolerance. We will obviously go through it, but there's a wee separate video for tolerance available. The gradient of each step should be less than a half. Mark thinks that the staircase will meet both of these rules. Is he correct? So let's work out rule number 1. It says that twice, and this is paper 1, so non-calc, twice the riser height plus the tread depth is between those values there. So we've got 2 times 170 is 340 plus the tread depth of 300, that's 640. That should be between 625 plus 15 or 625 minus 15. So we've got 2 times 170 plus that 300, we ended up getting 640. And then we've got 625 plus 15, that'll give us 640 for that. And then 625 minus 15, that gives us 610. So it is indeed between those, so it can actually, because that's the maximum that it can be, 640. So it meets rule 1. But the second one, it has to have a gradient that's less than 12. So let's picture the gradient of each step. So gradient would be like this. That's the gradient of each step. So the triangle is this. The height is 170 and the tread depth is 300. Both of them are in millimeters, so we don't need to worry about that. So we've got the gradient is V over H, and that would be 170 over 300. Simplifying that down, it would be 17 over 30. And it says that it should be less than half. Now, you could obviously work that out as a decimal and so on, but I think it would be enough to actually recognise that 17 over 30 is clearly more than a half. Right, a half would obviously be 15 out of 30. So that is greater than a half. So it meets the first one, but doesn't meet the other. So we write a wee statement saying, is Mark correct? So no. The first requirement is met as 640 is obviously in the range of 625 plus or minus 15, but the gradient of 17 out of 30 is greater than 1/2. So that means that it doesn't meet the requirements for this. Okay, so that's the end of the gradient video. So for gradient, remember those key points at the start. Let's make sure we use matching units. Make sure we use the correct values. Occasionally maybe we need to use Pythagoras, but that might be in another video for Pythagoras. We might identify some questions involving that. And if you're trying to compare between fractions and decimals, there are 2 steps or 2 ways you could do that. You could get matching denominators, or in some cases you can actually just look at the fractions and use some of your knowledge of fractions to work that out. Or, and this is a method I would use if you're not as confident with fractions, just recognise that you can do a division to turn them into decimals and then compare.